Okay, in this video I'm going to talk about solving quadratic equations, and we're going to look at two specific methods that can be used in order to solve those equations. First thing we have to start off with is that when we're talking about a quadratic equation, we are talking about making sure that your equations are in what's called standard form. Standard form of a quadratic is ax squared plus bx plus c. And when we're talking about an equation, we have to have these set equal to 0. Okay, so that is standard form. It means whenever you get or start working with a quadratic, you always want to make sure when solving that you put your equation into standard form. Now, one method that can be used for solving quadratics is to solve by factoring. So there's a few key things to remember about factoring. First, when using your factor method, you always want to rewrite into standard form. What this means is that you may be given equations that are all scrambled up, and so you always want to start off every problem when solving and put your equation into standard form. Now, the second thing that you want to do is you want to use factoring ideas or methods to reduce the quadratic into its parts. So in other words, factoring says we want to reduce our quadratic down to where we have, say, x plus or minus some constant 1 and x plus or minus some constant 2, where c1 and c2, so these right here, are your factors. Okay, they're the factors of your quadratic. Once you do that, your third step is you need to set both factored parts equal to 0 and solve for the variable. So what that means is that when we're talking about your solutions, you should have two solutions. So for the most part, we're having two solutions. The only time that you would ever see one solution would be if your two factors, so this part right here, were the exact same number and had the same sign. Okay? So let's take a look at an example. So we have this example here that says we need to solve that 4n squared, or n squared minus 4n minus 45. And we have to set this equation equal to 0 in order to solve. So that first step is we need to rewrite our equation so that we have n squared minus 4n minus 45 equals 0. So now the first thing we need to do is we need to factor it. So what you need to remember, of course, when factoring is that this first sign right here is going to tell you which sign combinations to choose from. And then the front sign tells you which is needed to use. Okay? So when we're talking again about sign combinations, we are talking about the following. So our sign combinations are as follows. You can have a positive times a positive equals a positive result. You can have a negative times a negative to give you a positive result, and a positive times a negative to give you a negative result. So the back term or the back sign tells you which combination you have to choose from. So in this problem, my sign is negative, so the only combination I have to work with is this last one, which says that my factors have to be one positive, one negative. Okay? Now, the other thing that we have to look at is we have a trick. And our trick is going to be used in order to help us determine which factor has to be positive and which factor has to be negative. So, the trick we have is as follows. If the sign of the B term is negative, like it is here, then it means the bigger factor is negative. Okay, so that is the trick to use, is that if the sign of your B term is negative, then the bigger factor is negative. So we have to look at factors of 45, factors of my 45, that when combined are going to give me the 4n. So I have my negative 45 here, and the first thing I'm going to do is I'm going to ignore the signs, and I'm going to write down all of my factors that exist for 45. So in doing so, I know some of the following. I know I have 1 and 45. Okay. I also know that I have 3 and 15. And then I know that I have 5 and 9. Okay? And so here, I've listed out my factors. Now the trick is going to tell me which factors are negative. So here it says if your B term is negative, then the bigger factor is negative. So my B term here is negative, which means my little factors, so the ones on the left, are all possibly positive terms. And the ones on the right, which are the bigger of those combinations, are all negative. Okay? So the math that I'm doing here is very simple. I am adding these factors together, and I am looking for which combination of these is going to give me negative 4 as a result. So I have 1 plus a negative 45 gives me a negative 44. I have 3 plus a negative 15 gives me a negative 12. And I have 5 plus a negative 9 gives me a negative 4. So when we look at these, the only combination that we could use has got to be my bottom combination here, because that's the only one that works. So I need to set up my factors. So this is going to be that I have my 2 sets of parentheses, and remember, I am set equal to 0. So my equation is going to split where I have n squared is going to break into n and n. So I have n and n. I then know, because of my signs, that I have one positive and one negative. And then because of my factors, I know my positive was 5 and my negative was 9. Thus, I have set up my factors the way I'm supposed to. Now, if I was just simply factoring this, I would be done. But the whole problem, or the whole point, was to solve. So this is where factoring is going to become a little different. And in order to solve, what it simply means is that I have to take each of these factors and set them equal to 0 individually. So I'm going to have n plus 5 equals 0. And I'm going to have n minus 9 equals 0. And what you have to do here is you have to solve both for the n value. So in this first one, I need to subtract 5 from both sides. So you end up having that n is negative 5. And then you have to add 9 to both sides. So then you have n is 9. And therefore, you have solved your problem. And so these were the solutions that we were looking for. N equals negative 5 and n equals 9. And if you were to plug either one of these solutions back into this equation here, you would get that 0 equals 0, which is what we want. Okay? All right. So now let's look at this one, which is going to use a different method of factoring. Here, what we have to notice is that my a term here, so my a is greater than 1. And because it's greater than 1, it means that I want to use that AC method to factor. Okay, so that is going to be the goal that we are going to do. And so we need to remember what that actually means. So to start with, the AC method says the first thing we need to do is multiply A times C. So in this case, my A was 7, so this is 7, and my C is 10. So A times 10 gives you 70. You then have to find factors of 70 that when added together will give you a negative 9. So again, once you find AC, the next thing that we need to do is we need to know the sign choice. Okay? So again, that's going to be the same as what we did in the previous, where this back sign here is going to tell us which combination we have to choose from, and the front sign is going to tell us which of those combinations we have to use. So, to choose from, says we need to multiply to a positive. That is what this back sign says. So I have two choices. Positive times positive equals positive, or negative times negative equals positive. Okay? The front sign here tells you which option you have to select. And since that front sign is negative, it means we have to choose my negative and negative. Okay, so that is the option that we have to use. So for here, I have to be able to find factors of 70 that are going to give me a negative 19, and both factors have to themselves be negative. So I need to look at 70. Okay, so I'm going to look at my 70 here, and I'm going to break down its factors. So I have the factors 1 and 70. I then have 2 and 35. I have 5 and 14. I have 7 and 10. Okay. So when I'm looking at these, what I know from my sign choice is that both of these signs have to be negative. So I can input my signs. And then I'm looking for which combination, when added together, is going to give me a negative 19. And so here, the only combination I have that's going to do that is going to be 5 and 14. So those are the factors that we have to choose. Okay, so these are going to be the factors. And so that means I can now start to set up my bottoms up to the AC method, which says I have to set up my factors in the form x. In this case, because they're negative, it's minus. And then I'm going to do factor over the a term. So that is my setup. So let's look at this. I've got my two parentheses. So I have x minus, my first factor is a 5, over my a term is a 7. So that goes 7 on the bottom. And then I have x minus, my next factor is 14, over 7 on the bottom. Okay. The next step you have to do is we have to reduce. So reduce says reduce the fractions. So in my first one, this is still going to be x minus 5 over 7. But my second fraction will reduce down. 14 over 7 becomes 2. So this is x minus 2. And the last thing we have to do is we have to do your bottoms up. So bottoms up says you have to take whatever is left in your denominator, and it has to bottoms up to become the coefficient to your x. So notice I have a 7 in my denominator here, so I have to bottoms it up. But on my second one, I don't have a denominator. My denominator is 1. And so therefore, I don't have to do anything with that. So I'm going to get the two factors that are going to be 7x minus 5 times x minus 2. So that is the factor piece. Now, we're trying to solve, which means I now have to set this equal to 0, and I have to solve both parts. So I have to take my 7x minus 5 equal to 0 and x minus 2 equal to 0. On the left, I have to add 5 to both sides and divide by 7. So x is equal to 5 over 7. And here I just have to add 2 to both sides. So x equals 2. And thus, we now have the two solutions to that problem. And so this was solving using that AC method. Okay. Now we have a totally separate method that we can use to solve quadratics, and that is called the quadratic formula. The quadratic formula is simple. We have x equals negative b plus or minus the square root of a whole bunch of junk. And that junk is going to be b squared minus 4 times a times c, and the whole thing is over 2 times a. So that is the formula that we have to use. And simply what you do with it is you are going to plug and chug your variables, okay, and nothing else. So here there are a few steps that we have to follow in order to do this. First, you must be in standard form. So you need to remember standard form: ax squared plus bx plus c equals 0. The second thing you need to do is you need to write out a, b, and c. So I would write them separately so that you know exactly the way that they're supposed to be. Because then the third thing you just have to do is you have to plug A, B, and C into the formula. Plugging it into the formula is going to allow you to then reduce your formula. So after you plug it in, the next thing you need to do is you need to reduce your formula, and then you're done. Okay? So these are the steps that you need to follow when using your quadratic formula. Okay, very simply, it's a plug and chug method used in order to solve it. Now, a couple notes about this method. Okay, first, so a couple things to keep in mind is that you may have radical answers. Now, we use the quadratic formula most of the time when you cannot factor. Okay, or I like to call it the fallback method, because it doesn't matter what equation you're working with, the quadratic formula will always work. So some things that you need to remember is that you may have radicals in your solutions. Okay. The other thing that you may have is you may have fractions. The last thing that you need to keep in mind is I would only ever give a decimal answer if asked to approximate. Otherwise, you need to give an exact answer, which would mean to leave it in radical form. Okay? So let's take a look at an example. So here I have solve using the quadratic formula, and I have 3x squared plus 7x equals -4. So again, that first step that we had to follow is we needed to make sure that our equation is in standard form. Well, this one is not. Therefore, I need to move this 4. So I want to take this 4 here, and I want to move it in this direction. Since it is negative, it means I need to add to the other side. So here my equation becomes 3x squared plus 7x plus 4 equals 0. So here, to use the quadratic formula, says I now need to identify my A, my B, and my C. So I need my A, my B, and my C. So these are going to be just the coefficients. So notice my A is going to be 3. Okay? Coefficients are the numbers attached to your variables. My B is the middle term, so it is 7. And my C is the last term, which is a 4. So I have to plug into the quadratic formula. Okay, so if we remember, that quadratic formula had simply said x equaled negative b plus or minus the square root of all my stuff, so b squared minus 4 times a times c, and the entire thing is over 2 times a. Okay, so I need to plug in. So I'm going to go ahead and do that. And let me grab the color here that is very different. Let's use this one. Okay, here we go. So I have x is equal to negative of my b plus or minus the square root of all this stuff. So this is going to be something squared minus 4 times something, and this whole thing is over 2 times something. Okay, so that's kind of the formula broken down. So let's look at plugging in what we need to plug in. So I have negative b. So my b was 7, so this is a negative 7. Plus or minus, it's b squared, so 7 comes in here to be squared, minus 4 times a, so my a was 3, times c, my c was 4, all over 2 times a, so 2 times 3. Okay. So I have input everything where it needs to go, and now what I have to do is I need to simply start simplifying things down. The best place to start is going to be to start with your radical. So I would start by simplifying this radical down. So I'm going to have that this is equal to my negative 7 plus or minus the square root of, and let's look at it. 7 squared is 49. And I'm going to subtract still because negative times positive is negative. And this is 4 times 3 times 4. So 4 times 4 is 16 times 3 gives you a 48. And this whole thing is over 2 times 3, which is 6. So I need to reduce again. So here I'm going to have a negative 7 plus or minus the square root. 49 minus 48 is 1. And this whole thing is over 6. There is still more that I can do, so I need to keep going. So this is going to equal my negative 7 plus or minus, well, the square root of 1 is 1, and this whole thing is over 6. So you need to, at this point, do the math. And what that means is I actually have two solutions here. I have negative 7 plus 1 all over 6, and I have negative 7 minus 1 all over 6. So negative 7 plus 1 is going to be negative 6. So this here is negative 6 all over 6. And when you reduce that, you get negative 1. So there is your first answer. And then on the other side, I have negative 7 minus 1, which is a negative 8. So this is negative 8 over 6. And I can reduce that. I can divide 2 out of both. So this is going to become a negative 4 over 3. And this is your second answer. Okay. So this would be the example of a quadratic that when you solve it, solves all the way down. and gives you whole numbers or fractions as a result. So meaning the radical dissolves and goes away. Now, what happens if we have one that looks like this? And so here we have negative x squared plus 1 equals a negative 2x. Again, you want to solve by using the quadratic formula. The instinct would be to move this 2x over. But let me tell you why you don't want to do that. This right here. Standard form has to have a positive a value. Because this is negative, what we actually want to do is we want to move everything to the other side. So we're going to set up our standard form by saying 0 equals, this is a negative 5x, so I need to add it to both sides. So I get 5x squared. My negative 2x is going to stay, so this is minus 2x. And then my plus 1 has to now be subtracted, so this becomes minus 1. Okay. So again, remember, standard form needs to have that positive a value. And so we're going to go ahead and move everything else over so that a becomes that positive result. Now I can go ahead and list out that I have a equaling 5, I have b equaling negative 2, and c equals negative 1. So what you have to notice here is that your signs are going to come along with. Okay. So with this, I now need to plug it in. So I have my same formula that is set up by saying x is equal to negative of something plus or minus the square root of something squared minus 4 times something times something. And then this whole thing is over 2 times something. Okay, so that is our setup. So let's plug our values in. My b is negative 2. So I have negative of my negative 2. And then b comes here. It's b squared minus 4 times a times c all over 2 times a. So now we have to reduce. So let's go ahead and look at this reduction. I have negative of a negative 2 is going to come out as a positive, plus or minus. And now let's look at the radical here. Negative 2 squared is going to be a 4. Negative 4 times 5 times a negative 1 is going to be a positive. Negative times negative is positive. And then 4 times 5 times 1 is 20. And the whole thing here is over 10. So let's finish reducing. This is 2 plus or minus. If we look at the radical, I have 4 plus 20, so this is a 24. And the whole thing is over 10. Now you can't stop here, because what we can actually do is we can reduce the square root of 24. So the way we do that is we look at how does 24 break down, and my index here for it being squared is 2. So I need to break my 24 down so that I can create a group of 2. So right off the bat, I know 24 can break into 4 times 6, and I know my 4 breaks down into 2 times 2. So this right here is considered my group of 2. So that's what pulls out. So 2 pulls out, 6 is left behind. So my square root of 24 actually is going to reduce to 2 square roots of 6. So knowing that, I can rewrite my equation now to compensate. So I have that this is equal to 2 plus or minus 2 square roots of 6 all over 10. Now we need to reduce our fractions. So to do that, I would separate them so you could see it. And what we actually have here is we have 2 over 10 plus or minus 2 square roots of 6 over 10. Well, 2 over 10 on both fractions is going to reduce. And so it actually becomes 1 over 5. So I have 1 over 5 plus or minus the square root of 6 over 5. So you can write it separate like this, or we can leave it combined, and you would say 1 plus or minus the square root of 6, and the whole thing is over 5. So either way that you would write these solutions would be completely acceptable for your problem. Okay? So that about sums up a really quick and dirty example on how to solve quadratics either by factoring or by using the quadratic formula. So as always, if you have any questions, please let me know. Otherwise, see you next time.